All right, ladies and gents, welcome back again. Now, I want to keep in mind that to some extent this video is optional. You only need to watch it if you are stuck on a problem. So it might be wise for you to skip ahead or, jump around in the video. But I'm going to explain as many problems as I can with the 15-minute time limit that my program allows me. So you will need your notes. Turn to page 13. That's where the problems are that we are going to work on. I would highly recommend you have your identity sheet out next to you. I've got mine so that I can kind of reference that as I'm trying to figure out what way we should take this. And a pencil. It's totally possible you can make a mistake, which is totally fine. Couldn't be more okay. You will make mistakes, especially in mathematics. But we need to be able to go back and easily erase so we can keep our work nice and neat. Can't do that with a pen. Just saying. All right, so with that, moving along, first problem. Remember from an earlier video and lesson, I talked about the fact that you want to pick just one of the sides and transform that. So I'm going to try every time to identify which side I picked. All right, left-hand side would be, like this side over here to the left of the equal sign. All right, and then the right-hand side would be this one. So in this first problem, for example, I'm going to pick the left-hand side, and the first step that I'm going to take is to make these both fractions. All right, and you might be thinking like, what do you mean by that, Mrs. Fry? Okay, bear with me on this. This is not a fraction. Cosine over 1 plus sine is a fraction, but tangent is a quotient. So I could rewrite it as sine of theta over cosine of theta. And then these would both be fractions. Oh, I realize I just used the wrong variable. My bad. Not that it really matters. As long as you use the same variable everywhere, but because the problem has x. I will change that, my bad. Cosine of x, 1 plus sine of x. All right, now, the second thing, so this is equal to that. That's our goal. I want to multiply this by cosine x over cosine of x, because cosine is the denominator over here. And I want to multiply this by 1 plus sine of x. 1 plus sine of x. I'm sorry if that's a little hard to read. I do apologize. All right, I'm going to make this, at least try and make this a little thinner. Maybe that'll make it easier to read. Okay, so when I distribute the sign, I'm going to get sine of x plus sine squared x. And then over here, cosine times cosine is cosine squared x. All of that over 1 plus sine times cosine. I'm going to leave that undistributed for now. All right, so again, one thing at a time. I combined the fractions. That was my one thing. The next thing I'm going to do between here and the next one is, hopefully you really need to start to see this, at least, this pair, sine squared and cosine squared. Hopefully you saw, those look familiar. On your identity sheet, they are a Pythagorean identity, and they are equal to 1. That means I really have the sine of x plus 1, right? This whole bubble becomes 1. And then that's over 1 plus the sine of x times the cosine of x, all right? Now you might be thinking, I still don't know how I'm going to get this cosine all by itself. Okay, up here in the numerator, that's really a factor, sine plus 1. Well, if you remember just your basic, arithmetic facts, it doesn't matter what order addition is in, all right, as long as both terms are positive. So guess what? Sine x plus 1 and 1 plus sine of x, they're the same thing. They cancel. Sweet. So that means we have 1 over the cosine of x, which is what I wanted. So now we're done. Cool beans. All right. Next problem. This one over here is another case of two fractions that we need to add together, all right? So, or subtract, I guess. So we are going to multiply by 1 minus sine of x. By the way, if you need to pause this video at any time, please don't hesitate to do so, all right? I'm going to pick the left-hand side because that seems more messy than these terms together, all right? It's a lot easier to put fractions together than to try and tear them apart. 1 plus sine of x and 1 plus sine of x. So, as promised, just to be clear, I'm picking the left-hand side, and I'm going to combine the fractions. And I'm currently in green. I've written everything to get a common denominator. Okay, now. Oh, that's no good. Now, I hope you remember a previous lesson in which we talked about the fact that if you have 1 plus sign, or 1 plus something, and 1 minus something, if you have the same factor, conjugates, you get a difference of 2 squares. All right? Hoping you remember that, because that's what happens to our denominator here. Then up here we get 1 plus the sine of x. Now technically we're subtracting here, so that's really a negative 1, and that's really a positive sine of x. Okay? So the ones, they appear to cancel. Okay? So it looks like we have sine of x, 2 sine of x's, okay, over 1 minus sine squared. Equals. All right. Now, if you haven't caught this trick, I shouldn't call it a trick. If you haven't caught this substitution yet, you could still substitute for 1. But the faster way is to recognize that this 1 minus sine squared is really just cosine squared. So I'm going to do this by writing this as cosine x times cosine x. Here's why. I haven't really talked about what our end game is. We want 2, we want tangent, and we want secant. All right? Well, I've got 2. All right, here's my 2. If I focus on just these 2 terms, I've got tangent. And this term right here, this cosine, there's a 1 hiding up there, right? Times 1. You can always multiply by 1. 1 over cosine, that's secant. Cool beans. 2, I keep saying that. I'm sorry, that probably is so retro and out of date, but that was a big phrase when I was in high school. I took trig when I was in high school, so you know, it's bringing me back. All right, you're probably thinking I'm really ridiculous right now. My apologies. All right, but hopefully that makes sense. Okay, if not, pause the video, go back, look at the work. There's kind of all the majority of the work. All right, next problem. Okay, number 3 is very similar. You want to add these 2 fractions together, and again, I would pick the left-hand side. Add fractions, common denominator. So for the sake of time, I'm not going to go through that problem explaining it out loud in the video, but the work is online, so you can go look that up. I'm going to explain number 4 because I think it's a little bit different. Okay, and I bring that up because I don't know that it really matters which side you start with in this particular problem, but for the sake of uniqueness, I'm going to pick the left-hand side. And the first thing I'm going to do is I'm going to split the sine cubed up. And I'm doing that because I don't know that you would necessarily think to do that, but I think it's going to work out pretty nicely. So here's the deal. We've got cosine of beta plus 1. And then I'm going to rewrite sine cubed as sine of beta times sine squared. As often as possible, I want to try and get a quantity squared in my expression because that I can change. How can I change it in this case? Well, I can't do anything to the numerator just yet. That's still cosine beta plus 1. Sine beta. But sine squared, if you look back at this problem, 1 minus sine squared is cosine squared. Well, sine squared is 1 minus cosine squared. All right? And you're probably thinking, yeah, I don't see this paying out. I don't see this helping. Okay, well, what's nice about having, sorry, I'm trying to rewrite this. What's nice about having something minus something squared? It's a difference of two squares. So really that's 1 minus the cosine and 1 plus the cosine. Hey, wait a minute. This is a factor of two terms that are both positive. This is a factor, the same exact two terms, both positive. Boom, those are gone. All right? So I'm left with nothing in the numerator at the moment, and sine of beta 1 minus cosine. All right. Well, that's really close to my my goal. This is my goal. All I need is I need something in the numerator, and I need it to be cosecant. Well, visualize this for a minute with me. 1 over sine. Look at your identity sheet. That's cosecant, right? In the numerator. 1 minus cosine. So that may seem a little weird, but this 1 over sine is cosecant over 1. So I can rewrite that. And that has gotten me to my goal. All done. Cool. All right, I think I've got time for one more. Which one do I want to pick? Tough call, tough call. Ooh, nope, that one's fine. Okay, I think I'm gonna do 5 because 5's super crazy. Okay, there's a lot going on here. Anytime you see a quotient in the top, it's probably best to deal with that left-hand side, and we're gonna split the fractions. So instead of putting the fractions together, we are going to split them apart. First step is I'm going to write tangent times 1 over secant. That's what I mean by splitting the fractions. I'm going to write cotangent times 1 over cosecant. All right? And now I'm going to change every single thing. Tangent is going to become sine over cosine. Secant, look at your trig sheet. That's cosine over 1. Cotangent, that's cosine. Right, same letter. Cosine over sine. Cosecant, that's sine. Oh, please tell me some nice stuff happens. Ooh, cosines go away. Sines go away. Sine of theta plus cosine of theta. Is that what I wanted? That'd be so cool, and it is. Look at that. Done. I'm sure I explained that really fast. My apologies. So like I said, too many things. I split them apart so that I could change everything to sine and cosine. Too many different types of functions. And then look at all the nice canceling that happened. All right, I was not correct. I have enough time for even another problem. I'm going to do 7 because 7 looks way more intimidating than it really is, okay? First off, left-hand side. I know this probably seems ridiculous that they're all the left-hand side. I'm going to do the left-hand side, and I'm going to substitute a Pythagorean identity. If you're like, Mrs. Fry, how did you see that already? It's not because I'm good. It's because there's something squared. Whenever there's something squared, the only identity that has a squared is the Pythagorean identity. Okay, so that's the main reason. Of these two, the denominator is the one that's a Pythagorean identity. So 1 minus tangent squared x over secant squared x. I gave a pause so that hopefully you could look that up. That's secant squared x. All right? Now, secant squared, let me back up. The problem's goal does not have a fraction. So I'm going to get rid of the denominator by rewriting it. That's my next step. I'm going to change secant squared, being in the denominator, to cosine squared x. 1 minus tangent squared. And then I'm going to distribute it. So cosine squared x minus cosine squared x tangent squared x. All right. I hope you can see where this might be going. At the very least, like I said, I'm going to try to be true to my word. I'm only going to do one major thing at a time. So I'm going to change this to sine squared over cosine squared, and you're going to have to watch the rest of this